Hello, in this video I'm going to go over the tile format of the Mega Drive, and I will also preview my tile converter for converting images into the correct format for use with the Mega Drive. So let's get into it. Right, first off I will go over the colours of the Mega Drive. So as in my specs video, I went over the correct format for the Mega Drive here. So in these three here you can see examples of the colors. So the palettes need unsigned 16-bit numbers to represent them. It's in a 9-bit color format. Makes sense, and it's easier to view all of these when viewing them as hexadecimal numbers here. So the first byte is not used, and then we've got red, green and blue here, which is nice coming from desktop usage. So one thing to be aware of is the color values themselves are only 0 to 7. So you've only got 8 color step ranges in each of the 3 colors. So to get these here we have to multiply the 0 to 7 values by 2. So we can either have 0, 2, 4, 8, A, C or E as the actual colours of the red, green and blue intensities. So to convert from PC colours to Mega Drive, the simplest way is to just think of these as steps of 32. So the 0 will always be black, and then you won't actually get to the first colour until 32. So you would go up with 0, 32, 64, 96, 128 and so on and so forth. I will obviously give some example tiles in a moment once I go over the format. So the other thing with the tiles on the Mega Drive, it's a lot easier to actually see the tile data when the 16 color tile format for the Mega Drive is the same one which is adopted by the DS when it has 16 color tiles, and is a nice format. It uses unsigned 32-bit values to represent the colors here. So here's our example tile, and then this is an unsigned 32-bit hexadecimal number here. So each of these is actually a nibble. So you can think of each of these numbers here can be a number between 0 and F, and that corresponds to that pixel's colour from the colour palette, which makes this a nice format to actually work with and actually see what's going on. So we can easily take this here, put it into an array of unsigned 32-bit numbers, and then easily tweak around with these values and then send that to the VDP and then draw that tile on the tile map, and it's straightforward to see what's going on, which we will do in a moment. But first off I will show you some example tiles which we will use with my Mega Drive tile converter. So first off, like I was saying before, so when you create the colours here for your tiles, you can think of it as going up in steps of 32. Obviously we can't get to 256, so that one is 255 is the max here, although when you do this, you'll see that anything over 224 will be the max value of the color there when working with this. So all the colors you put in here should be steps of 32. If you're going to use the graphic converter that I will provide, I have a Windows and a Linux version, which I will post the source code for the Linux version as well, and the Windows version will have a binary which is already built that in Windows 7, so that should be fine for everything, although it was 64-bit. If you need a 32-bit one, then you might want to download the source code and build it yourself. So these are all straightforward here. These are our tiles. So now let's open up a Code Blocks project. If you're new and you're here for just the Mega Drive stuff, then I have previous videos showing how to install Code Blocks on Windows or Linux, and I also have a video showing for Linux how to set up SGDK using MarsDev. I haven't provided a video for setting up SGDK on Windows. If you navigate to their website, or sorry, rather their GitHub site, there will be a load of info there. I've had issues trying to install the Windows version. Previously I was able to install the older versions fine, but I keep getting errors with the latest version. So yeah, hopefully you'll be okay. If not, then let me know if you need any help. Right, so now I will create a new Code Blocks project. So first off, if you've already installed MarsDev, then what you want to get is go into the examples here, and then when you build your first project, we want to make sure that we use the skeleton to build off of. So we'll create an empty project. So I've already previously set up a whole sort of a structure for where I'm going to store all my Mega Drive programs. And in my previous video I showed how to set up a compiler to use MarsDev. So now we've got our blank project here. The simplest way to carry on is to go to the MarsDev folder here, and then open up where you created your new project, and then just copy the source across there and the make file. Now all we do is go on to add files recursively. We don't want the boot header, we just want the main file there. There we go. Now if we build that, yeah, we don't need that. Let's try that again. Nope. Okay, let's set up the project. that's the issue you'll get on the Windows one there, so it's obviously not able to find stuff. So this is a custom make file here, ours is in the folder. Should be fine there. Let's try that again. Oh yeah, we don't need that. So let's try that again. And then, yep, that's all built now. Now what we need here, so these data types here are already part of SGDK. If you've not done so already, I recommend now that we've got this, you've got this set up nicely, to save it as a template, and then just call it or something of that. You might want to put like a date in there as well. I've already done this, so if I need to create a new project, I can literally just use a template which has all this stuff configured for you nicely here. So now what we want to do is create an array here for our tile, and let's also create a color palette as well. As I said, it's very simple to do on the Mega Drive. So we want a nice blue color for our background, so let's try that. So that will be our sky blue back color, and then our tile, a smiley face, will have yellow, and then we'll just include two colors for now. And then so we'll start at color 0, and then we'll put in our palette. We've got two colors, and our transfer method will be CPU. And then take all this, as that is already set up there. Now I will double check my other program a minute to see what command I'm actually using. To draw those tiles. There we go. So here's our array. I'll start at tile 1, and then 1 tile. Now ints on the Mega Drive are 16-bit numbers. As we're working on the Mega Drive now, I'm going to try and keep numbers in the 16-bit if possible. Unsigned 16-bit numbers are the fastest for the processor to work with. And then we'll use the first plane. I believe it sets us up already in right now we've built that one. Let's try and run it. So that will build it here. So let's open it with Blastum. And there we go. The colours are not quite right. So it's in the blue, green, red format, I believe. But as you can see, the tiles are fine there. So let's tweak the palettes there. So the palette format must be blue, green, red, sorry. There we go, that's as expected. So as you can see, there's our smiley face there. We've got our sky blue background. So that's fine there. So yeah, it's arranged blue, green, red color wise. So now let's get into the tile converter and then we'll paste in our palette and tiles. So here's the location here. So we want to make sure that we once our image tiles are saved, then copy them into the same location as the executable file, and then open up a terminal window, get to the location, and then put in the name of the file you want to convert. Our blocks are 8 by 8 and there are 16 of them. And then if everything went fine, it will create a temp folder and then put in the name of your blocks. And that's that. If we open it with text editor, it's created the correct palette for us there, and here are our blocks laid out in sets of 8 here, so 8 of these equals 1 tile. So if we go back to here and then we copy our palette across, and then if we copy our tiles across, so as we can see here, we've got what, that's 11 colors there. and then we can start loading the tile data at tile 0, as I left in an empty one there at 16. Now what I can do here is if I do that, that will show us all of the tiles there. We'll build that again. Now if I open that program up again, and there you go, there's our tiles. Obviously you would need the correct sort of function to lay out the 16 by 16 pixel tiles there, but they're all there. So that's it for this example. Oh yeah, if you wanted to do sprites as well, as per the README file, which is included with this here. So depending on what size of your sprites, make sure you add in the tiles go down option there, because sprites are arranged going down. So as an example here, if we had a 32 by 32 sprite there, and then we'll split that into 8 by 8 blocks there. So the sprites themselves they need to be arranged going down like that first, and then going down in the next lot there. So they would take it going down in rows like that. So the tiles need to be arranged separately. Now if you only had a 16 by 16 sprite, then you would just have these here, but it would take them, so that would be the first, and then that would be the second tile there, that would be the third, and that would be the fourth if it was a 16 by 16 sprite. If it was 32 by 32, then this would be the third, that would be the fourth, that would be the 5th, 6th, 7th, 8th, and so on up to 16. So that's it for this. I will provide links to all of the source code and the binaries in the description to the video below. Let me know if you have any questions over this, and I will try and get back to you. Okay, that's it for this video. Hopefully it's been useful to you.